In this video for section 16.1, we're going to talk about something called forecasting. Forecasting is predicting what the future will be like. So for example, the weather forecast is predicting what the weather will be like. Planning is determining how you're going to deal with the future based on the forecast. So after you watch the weather forecast, you might, for example, plan to take an umbrella with you. The forecasting horizon is how far ahead you want to look. So you could be looking in the immediate term, less than 1 month, the short term, 1 to 3 months, medium term, 3 months to 2 years, or long term, 2 years or more. And which term you use really depends on what you're trying to do as a business. Sometimes you might look in the short term for short-term planning purposes. Other times you might look at a more long-term forecast. The forecasting period is the unit of time that you're making forecasts for. It could be a daily forecast, a weekly forecast, monthly, quarterly, or yearly. In order to make a forecast, we have to have historical data that matches the forecasting period. So if we want a weekly sales forecast, if we want to predict the sales per week, we cannot base it on yearly sales data because we won't see those variations in week to week if all we have is the information about what sales were per year. We need weekly sales data in order to make a weekly sales forecast. Time series data is data collected over a period of time. And we can make a time series plot, which is also called a line chart. It's a graph that displays this data, and time is always on the x-axis with a time series plot. So we're going to look at this business application problem. We have an office supply company that wants to forecast revenues for the copier service portion of the company. And our questions are, has demand for copier services generally increased or decreased? And are there times during the year when the demand is typically higher than other times? So we want to look at the overall trend, and we also want to look at the year and see if there are times when the demand is higher or lower than other times. So I have this data in Minitab. We have the months and the revenue per month. And so what we're going to do to make a time series plot is go to Graph, and then the very last choice is Time Series Plot. You can also get this by going to Stat and going down to Time Series, and you'll see the option for Time Series Plot there as well. It's the same thing. I think it just makes more sense to find it under Graph since we want to make a graph. We're going to use the simple plot. In the y variable box, we're going to put what we want on the y-axis, which is going to be revenue. So click Select to put that in the box. Then I need to click on Time Scale. Then I'm going to select Stamp, and in the box, I'm going to put what I want on the x-axis. So in this case, that's going to be month. That should always, again, be a unit of time if it's a time series plot. Click OK and click OK again. And here is my graph. So we can see that the overall trend is that sales are increasing. So that's a good thing for the company. You want to see an overall pattern of increasing sales. I can also see, though, that there are some spots where it's going down. And it's a little bit hard to see here because of the scale that Minitab decided to put on the x-axis. But you can kind of see there's like a decreasing period here up through March-ish, and then there's another decreasing period around here, around January, another decreasing period through here. So it looks like it's decreasing from about the end to the beginning of the year, maybe around January through April. And there are long periods of increasing sales through the end of the year. So we can see through the end of the year, the sales are increasing through those months. So I'm going to copy my graph and paste it. If I wanted to into my Word document, I won't do that here, but I'll just write my observations. So we'll say that demand has generally increased. With higher demand we'll say in the months May through December. Demand or sales really is what we're looking at. Decreases from January to April. And so we don't really know why that is. It might be that companies aren't necessarily needing copies at that time of the year. Maybe it's the post-holiday, they need less copies. So the company could do some analysis work to figure out why their sales are decreasing through those months, but that's what the data is telling us. So, time series data may exhibit one or more of the following. The trend component is the overall long-term increase or decrease over time. It could be linear or a nonlinear trend. If it's a straight line, or it could be a different shape, you might have more exponential growth, which would be great. A seasonal component would be more of a wave-like pattern that repeats on a yearly basis or more frequently. So it could be a quarterly pattern, it could be a weekly pattern, or it could be a daily pattern. So something like toy sales, you would expect that to be highest around the holidays in December. If you have a restaurant might see their sales pattern on a weekly basis. Their sales might be highest on Saturdays. Or you could look at daily trends, like also in a restaurant. There are certain times of day where the restaurant might be busiest, and other times of day where the restaurant is less busy. So those would all be considered seasonal components. A cyclical component is something that repeats less frequently than yearly. So it's a longer term kind of up and down. And then a random component would be not an identifiable trend or pattern in the time series graph. And then the next thing we're going to talk about is index numbers, and these are used to compare values at different points in time. So first you select a base period index and set that equal to 100, and then you use the formula to calculate other values, and this is the formula here. So what you're doing is you're taking the value of the time series at the time t and dividing it by the value at your index base period and then multiplying it by 100. This formula probably makes it look a little bit more complicated than it actually is. It's a pretty simple calculation. So looking at example 16.1, we have managers who are considering purchasing another company, and to gain a better understanding of the sales history, they want to convert that company's sales data to index prices. Using 2006 as the base period, calculate the index prices. So we're going to use 2006 as our base period, which means we're going to set it equal to 100. A lot of times it'll be your first value that you want to set equal to your base period, but not necessarily always. Then what I'm going to do is for each later value, my YT here is going to be the value in that row, so that would be 15.2. So I'm going to do 15.2 and divide it by my Y0, the value at my base period. So that's 14. So 15.2 divided by 14 and then times 100. And if I do that, I can do that on a calculator, I would get 108.6. Same thing for 2008. I would do 17.8 divided by 14. So you're always dividing by your base period amount and then multiplying by 100. If I do that on a calculator, I should get 127.1. And the nice thing about using the index numbers is it can give you a sense of the percent growth rather than looking at raw numbers where it's a little bit harder to see. So I can see like from 2006 to 2007, the growth increased 8.6%.